Now we need to review the theory behind how a monopoly makes its decisions. So let's start by thinking about the characteristics of a market that is a monopoly. So our characteristics, obviously the first one is that there's only one firm, a single firm. The second characteristic is that there's just one good with no close substitutes. So there's no differentiated goods. We could say that it's an identical good, but that makes it sound more complicated than it is. It's just one good with no close substitutes. And then the third characteristic is that there is no entry. There are barriers to entry. We'll talk later about what those barriers to entry are. But those are things like maybe that firm is the only firm that has some key input. Or maybe it's a natural monopoly. Or maybe it's a patent that grants this firm to be the only firm that can profit from some invention. So those are our characteristics. The thing that this does is that this now means that this one firm is the one whole side of the market. They're the whole supply side of the market. That means that the monopolist faces the market demand curve. So the monopolist faces the market demand curve. This is important. This is different, obviously, from a competitive firm, because a competitive firm faces that perfectly elastic demand curve. It's perfectly elastic because there are perfect substitutes for what each competitive firm sells. There's no substitute for what this firm sells, so anybody that wants to buy has to buy from this single firm. Obviously, that we say that the monopoly is a price maker. They choose their price. Now, the monopoly obviously is limited by consumer willingness to pay, so they can't just choose any price they want. If they choose too high of a price, nobody will buy the good. But they have control over the price. We would say that they have market power. The monopoly has market power. That's the phrase that we use when we talk about a firm that has control over the price. Now, because the monopoly faces the market demand curve, if they increase the quantity that they sell, it drives the price down. So for the monopoly, there's an inverse relationship between the quantity that they sell and the price that they can charge. We could think about what that looks like graphically. If we were to think about the market demand curve, I'm going to call that big Q now because this is a picture of the monopoly, but this picture is also a picture of the market because the monopoly is the only firm. So I'm going to draw our demand curve. This is obviously an inverse demand curve because I've got P up here. But let's think about this situation right here where we've got the firm producing Q1. That means the price in the market is going to be P1. If the firm wants to sell more, then if they sell Q2, that means the price is going to fall to P2. So if the firm produces Q1, let's say firm produces Q1, then that means that total revenue would be equal to P1 times Q1. There's the total revenue that the firm will produce. If it increases production to Q2, firm now produces Q2, then its total revenue is going to be equal to P2 times Q2. P1 times Q1 is this first rectangle right in here. That's the revenue that the firm will earn if it produces Q1. If it produces Q2, it's going to earn a different area. It's going to get this rectangle right down here. So it's going to gain this chunk. This is gain. But it's going to lose this. Say that part's lost. So there's this trade-off. The monopoly can produce more and sell more, but it's going to have to sell every unit for a lower price than it did before. Now, whether or not the firm is better off when it goes from Q1 to Q2 or worse off obviously depends on elasticity. It depends on whether this gain area is bigger than that loss area. The point of this is that the way that marginal revenue is calculated for the monopoly is different, very different from the way that we would look at marginal revenue for the competitive firm. When the competitive firm changes its output, it has no impact on price. When the monopoly changes its output, it has an impact on price. So let's talk about marginal revenue for the monopoly. So we've got, let's say, consider a demand curve that looks like this, A minus B times Q. Nice general demand curve. Our total revenue, we know, is just equal to P times Q. But now, if this was a competitive firm, that P would not be changing, but it's not. It's a monopoly, so that P right there is a function of Q. It's a function of how much output the firm produces. So instead of just writing that as P, I'm going to plug in what it is. It is A minus B times Q multiplied by Q. That's what total revenue looks like for a monopoly, because changing quantity changes its price. I'm going to distribute that Q through. That's equal to AQ minus BQ squared. There's what total revenue looks like for the monopoly. We want marginal revenue. So marginal revenue is the derivative of total revenue with respect to Q. And if you take the derivative of this, you get A minus 2BQ. And this gives us that well-known result that the marginal revenue curve for a monopoly has the same intercept as its inverse demand curve, and it has twice the slope as the inverse demand curve. The slope of the inverse demand curve is B. The slope of the marginal revenue curve is 2 times B. So what we get is that rule that for a linear demand curve, the firm's marginal revenue curve has the same vertical intercept and twice the slope. Same intercept and twice the slope as inverse demand. So now let's draw a picture here of the profit maximizing choice for a monopoly. So I've got price up here, I've got Q down here. Let's make sure that we just label this as monopoly. It's a picture of the firm. It's also a picture of the market, because the firm is one whole side of the market. So we've got our demand curve, inverse demand curve looks like that. Now, with this rule, we can draw the marginal revenue curve because it has the same vertical intercept and twice the slope. It looks like that. There's our marginal revenue curve for this monopoly. Let's put our marginal cost on here. I'll go ahead and put my average total cost. I'm going to put it somewhere right in here. There's average total cost. So there's a picture of the cost information for the monopoly and the revenue information. What we need to look at is where marginal revenue equals marginal cost. That happens right there. So for the monopoly, the profit maximizing quantity to produce is right here. I'm going to call it QM for the monopoly quantity. Now the monopoly has control over the price. The monopoly is a price maker, and the monopoly wants, once it's decided what quantity it produces, it's going to charge the maximum amount it can for that quantity. So we go up from that quantity to the demand curve to see consumers' maximum willingness to pay for that level of output, and it's right there, which means that the monopoly will charge that price, PM. If we want to identify the profit that the monopoly will earn, then we've got, remember that profit is equal to price minus average total cost multiplied by Q. We've got the price and we've got the quantity. We need the average total cost. So if we go up from that quantity to the average total cost curve, we hit it right here. There's the average total cost of producing that level of output, which means that the area of that rectangle right there is the profit that the monopoly is going to earn. So there's a monopoly earning a positive profit. Being a monopolist doesn't guarantee you a positive profit. If the demand curve were to shift to the left enough to where that it was below the average total cost curve, then the firm would go out of exit the market in the long run. But with the demand curve where it is right there, that monopoly earns a positive profit. So essentially what a monopoly does is it uses its market power to restrict quantity and drive price up, and that maximizes profit for the monopoly. Let's think about working through a problem like this where we use the same market demand curve that I used in the perfect competition problem, and let's just see how things would work out with the monopoly. Let's suppose that that industry, instead of being a perfectly competitive industry, was a monopoly. So let me clear this off and we'll work through that problem. So let's use the same market demand. So we've got market demand, that was Q equals 6,000 minus 50p divided by 9. Now let's suppose that we've still got the 50 plants. In that problem, the perfect competition problem, we had 50 firms. Let's suppose those are just 50 plants all owned by the same owner. So it's just one firm with different plants for making the good. So let's say, suppose the 50 firms are plants owned by one monopoly. And we'll stick with that assumption that each plant has the same cost curves. That keeps things simple. So our cost curve for an individual plant looked like this. This is our total cost. It was 100 plus 10Q plus Q squared, which meant that our marginal cost was equal to 10 plus 2Q. What we saw was that the total quantity total quantity produced by all 50 was this. QS equals negative 250 plus 25P. So we got that by looking at the individual supply for a firm and then adding that up across 50 firms, and then we ended up getting that as our firm supply curve. Turns out that if we invert that, that gives us what the monopolist's marginal cost would be. So if I invert, let's say to get the monopoly marginal cost. Remember that the monopoly has no supply curve like we would have with a competitive firm. The competitive firm's marginal cost curve, we call it the supply curve. And the reason is because once you have the marginal cost curve, you've got everything you need to know. The price and quantity combination are both found on that marginal cost curve. A monopoly has no supply curve. A monopoly still makes a supply decision. It's just that the price and quantity, you need 3 different curves to figure out the price and quantity. You need the marginal revenue and marginal cost to figure out quantity, and then you need the demand curve to figure out price. So for the marginal cost, or for the monopoly, that what we would call the supply curve for a perfectly competitive market, that would actually just be the marginal cost curve for the monopoly. Okay, so that's why we're going to invert that supply curve that we got from perfect competition, and we're not going to call it the supply curve for the monopoly, it's just the marginal cost curve. So if I invert that, I get 25P equals 250 plus Q. I'm going to drop that S because we're not going to call this the supply curve. That means that marginal cost, which is P, I'm solving for P. I'm going to divide through by 25 here. That's going to leave me P, but it's going to be my marginal cost. That's going to be 10 plus Q over 25. There's my marginal cost curve for the monopoly. Okay? We've got our market demand curve. We need the monopoly's marginal revenue. Monopoly's marginal revenue curve. So what that means is we need to invert the demand curve to get the inverse demand curve. And then we just need the intercept and twice the slope, and that's going to give us the marginal revenue curve. So I'm going to invert this. I'm going to multiply through by 9. That gives me 9Q equals 6,000 minus 50P. I'm going to take my 50 over here and my 9Q over there. I get 50P equals 6,000 minus 9Q. And then I'm going to divide through by 50. That leaves me P over here. 6,000 divided by 50 is equal to 120 minus, I'm just going to leave it as 9 over 50 times Q. There's the market inverse demand curve. I can use that to get my marginal revenue curve for the monopoly. That means that my marginal revenue curve has the same intercept and twice the slope. So I'm going to say minus 2 times 9 over 50 times Q. I can rewrite that as 120 minus 9 over 25 Q. There's my marginal revenue curve. That's what I'm really after right there. So I've got most of what I need. Actually, I think I've got everything that I need right now. So I'm going to draw a line here. We need to look where marginal revenue equals marginal cost. So I'm going to say set marginal revenue equal to marginal cost. And that's going to give us the equilibrium quantity that the firm produces. So my marginal revenue, 120 minus 9 over 25 times Q equals my marginal cost, which is right here, 10 plus Q over 25. So I'm going to move the 10 over here. That's going to leave me with 110 over here. So 110 equals, I'm going to move this 9/25 Q over here. It's going to give me 9/25 Q plus 1/25 Q. I've got a common denominator here, so I can add those up. That gives me 110 equals 10Q over 25. So I've got 9Q over 25 plus Q over 25. That's 10Q over 25. That gives me, I'm going to multiply through by 25. That gives me 2750 equals 10Q. Q equals 275. There's the profit maximizing quantity for the monopoly. So I'm going to plug that in. So that's my quantity. Now I need to plug that in. I can plug it in. Probably the best place would be to plug it in right here. So plug Q, let's say plug Q equal to 275 into the inverse market demand curve. So P equals 120 minus 9 over 50 times 275. That's equal to 120 minus 49.5. That's equal to 70.5. There's the market or the profit maximizing price for the monopoly to produce. Now, the monopoly is going to produce 275 units, but it's got 50 plants. So if we divide 275 by the number of plants, that tells us how much it's going to produce in each plant, and that will be produce 5.5 units in each plant. Produce 5.5 units in each plant. We can think now about the profit that it's going to earn in each plant. So profit for each plant. So let's do it this way. Profit, let's do total revenue minus total cost. So profit for each plant, we need the price, which is 70.5, times the quantity for each plant. That's this quantity. That's times 5.5. And then minus our total cost. So that's 100 plus 10 times Q. 10 times 5.5 is 55. Plus 5.5 squared, that's 30.25, 30.25. I'm running out of space here, I apologize. So that's equal to $387.75 minus 185.25. That gives us $202.50 of profit for each plant. If you wanted the total amount of profit for the monopoly, just multiply that per plant profit times 50. So this is a nice simple problem that allows us to compare what happens with perfect competition with what happens with monopoly. So let's draw a line here and let's just compare the two. So if we think about perfect competition versus monopoly, we can think about the quantity that's produced. So what we saw with the quantity produced in perfect competition, in that problem it worked out to be 500. And with monopoly, we see that the quantity is 275. So in terms of quantity, the monopoly uses its market power to restrict quantity. It reduces the quantity produced. In terms of price, what we saw with price with the perfect competition problem was that the price was $30. And what we see with monopoly is that our price is equal to $70.50. So the monopoly uses its market power to drive that price up. And then in terms of profit, what we saw with perfect competition is obviously it's $0 per firm. Firms make zero profit because price is driven down to average total cost. And with monopoly, what we see is that it's $202.50 per firm. If you multiply that by 50, you get $10,125 of profit made by the monopoly. So you can see that being the monopoly, that's a good thing if you're the monopoly. What we need to do now is we need to talk about comparing the two. So we need to discuss economic efficiency. I'm going to clear this off and then we'll take a look at that.